Hello, pre-AP Physics. Welcome back. Got another video for y'all. It's going to go a little more in depth on acceleration. I know what y'all were thinking. Mr. T, that last one was pretty easy. It was really just one formula. Is that all there is? No, that's not all there is. Not for pre-AP at least. So today, what I'm going to do is I'm going to go over the additional formulas needed for acceleration. The last video you watched had this formula. Acceleration is equal to the change in velocity divided by time. So there are other ways to write this formula. There are ways to derive these additional formulas I'm going to show you. I'm not going to go into how to derive them, how to get them, because that would probably add a good 20 minutes to the video. If you're curious about it, if you have some free time, come and see me and I will show you how to get to them. But otherwise, without further ado, these are the extra equations. The three primary ones we're going to use are these. So as you can see, they're a little more complicated than the previous acceleration formula, but they generally have similar information in them. So this first one is displacement is equal to initial velocity times time plus 1/2 the acceleration times the time squared. So all that squared means is that the same variable times itself. So if it was 2 squared, it'd be 2 times 2. If it was 10 squared, it'd be 10 times 10. Since it's t squared, it's t times t. We have final velocity is equal to initial velocity plus the acceleration times the time. And then we have final velocity squared is equal to initial velocity squared plus 2 times the acceleration times the displacement. So those are all used for different things. These formulas actually are very common if you're building cars or other mechanical objects. If you want to check how far it takes for something to stop, like if you're safety testing a car, if you want to see how quickly a plane, see how much time a plane has to accelerate before it takes off. So you have to know how long to make your runways, things like that. These all see use. A little more use actually than the previous easier formula we went over. So without further ado, let's try a couple practice problems. First one, Irma is approaching a stoplight with a velocity of 30.0 meters per second. The light turns yellow, so she slams on her brakes. Her car skids to a stop at a rate of negative 8.00 meters per second squared. How far would her car slide until it came to its complete stop? So this is the instance we want to figure out how far would this car slide before it actually stopped. This is important if you're making cars and you want to safety check it. Is your car actually safe if it's going at the, say, a normal speed on the road? One of the things you may notice is this acceleration is negative. Anytime you have a negative acceleration, that puts a negative sign in front of it. So if somebody's talking about decelerating or slowing down or negative acceleration, keep in mind that acceleration is always going to be negative. So give this problem a try. Pause the video, come back, see if you can solve it on your own, then see how I do it. All right, welcome back. So let's see how I would solve this. We're going to use a guess method. So first, G, what are we given? I'll start with negative 8.00 meters per second squared. That's acceleration. We have 30.0 meters per second. That is our initial velocity. And then do we notice anything else? There is one more thing we're given. We are actually given final velocity. Now, there are no other numbers in the problem, but we need to know the final velocity is going to be 0 meters per second. Why? Because it comes to a complete stop. All right, so we have 3 givens. Next is U for unknown. What are we looking for? How far? So how far would her car slide? It's displacement. Or D. So now we have a D, a V sub F, an A, and a V sub I. So we want to try find a formula that has all those things, but nothing else. So this first one has a D, good, V sub I, good, T. Yeah, we don't have a T, so can't use that one. Next, V sub F, good, V sub I, good, A, good, and T again. Can't use that one. This one, V sub F squared, good, good, AD. Okay, so this is winner, winner, chicken dinner on this one. We're going to go ahead and use that formula. So, equation is equal to final velocity squared equal to initial velocity squared plus 2 times the acceleration times the displacement. All right, one problem here though, unfortunately, this formula is final velocity squared, but we're looking for displacement, so we got to rearrange this. So first thing I'm going to do, subtract v sub I squared from both sides. Those cancel. That gives you v sub f squared minus v sub I squared equals 2AD. Okay, so we need d by itself, so I'm going to divide by 2a, cancel, divide by 2a. So that leaves you with v sub f squared minus v sub I squared over 2a equals d. All right, yay, we found d. So now let's substitute v sub f 0 squared minus v sub I, that's 30 meters per second, squared over 2 times the acceleration of 8.00 meters per second squared. All right, so then you end up with 30 squared is 900, but it's 0 minus 900, so negative 900 meters per second divided by, ooh, I almost made a mistake here. It's a negative 8. 2 times negative 8 is negative 16 meters per second squared. So negative 900 divided by negative 16, solve, is, calculator says 56.25 in meters. Or if we're going with significant figures, 56.3 meters. Yes, that is a little bit of math, but that's a pretty common and useful physics problem there. All right, let's try one more. Ben is at a stoplight. When it turns green, he accelerates from rest at a rate of 6.00 meters per second over a time period of 4.10 seconds. Determine Ben's displacement during this time. All right, so guess. G. What are we given? Well, we're given 6.00 meters per second squared, and that's acceleration. We're given 4.10 seconds, and that's time. Anything else we're given? Hopefully you tried working this out on your own first. The good old invisible one, initial velocity. So v sub I is equal to 0. Why is it 0? Because he is at a stoplight and he's starting from rest. So when you start from rest, you're starting with an initial velocity of 0. All right, what are we looking for? U. What's his displacement? Well, it just comes out and says we're looking for displacement. Or D. So what equation? All right, so we need an equation that has D, T, A, and V sub I. Let's take a peek. D, V sub I, T. Perfect. Look at that. First time's a charm. So we need displacement. We have acceleration. We have time. We have initial velocity. Can't use this one, unfortunately. I mean, if we were looking for final velocity, we could, but we're looking for displacement. There's no displacement here. Can't use this guy over here because there's no time. And we don't have a final velocity. So, gonna go with the first one. So, displacement is equal to V sub I times T plus 1/2 acceleration times time squared. All right, and this one's even easier because it is literally already set up to look for displacement. Yay! So let's substitute V sub I is 0 times 4.10 seconds plus 1/2 times 6.00 meters per second squared times 4.10 seconds squared. All right, now time to do our handy dandy math. So first things first, made it easier. 0 times anything is 0, so boom, big ol' 0 there. Plus 1/2 times 6.00 meters per second squared times, let's do 4.10 squared, so that's 4.10 times 4.10. Calculator tells me that comes out to 16.81. Okay. All right, so then we multiply these guys out. So 6 times 16.81. That is, calculator, so 0 plus 6 times 16.1 times 1/2, 50.43 meters, because the second squared cancel out the second squared. So our answer then, our solution, last S, is 50.43 meters, or with sig figs, 50.4 meters. All right, so I notice this is a little more math than maybe some of y'all wanted. Take a deep breath. It's okay. This is why it's pre-AP. It's all right, but I know you can do it. So in class, we're going to be going over some problems like these. I have practice problems set up on It's Learning. They should appear when you're done watching all of these videos. You can try them unlimited times. I will be around to help. It's okay. We'll get through it. I promise. So, see y'all in class. Have a good one, everybody.